Hello, this is Chad Germany, and I'm basically going to do some questions from the test we just took in statistics, and I'm going to review counting. So there it is right there. I'm going to review some counting questions, and I'm going to do so within 10 minutes. Alright. This is my first video, so please bear with me. Alright. Oh shoot. Okay. Okay, can you see this? Sorry for the glare. Alright, let me get the light out. Okay. This keeps coming back. Okay. Alright, is that one? Okay, let me just read it to you. How many different ways can we sit 5 boys and 6 girls in a row of 11 chairs if its end seats have to be boys? Okay, we've done this problem before, so what you do is you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because 6 plus 5 is 11. And on the end seats, there has to be 5, 4. It has to be a boy. You can choose between 5 over here, but once you've chosen 1 out of the 5, then you have to choose between 4. 1 out of 4. So you have 4 over there. And basically, in between these different spaces, in between all these spaces, you have 6 plus the 3. So you have 9 factorial kids in here. Because after you've chosen 2 kids, 2 of the boys, then you're going to have 3 boys left, and you could mix them in with the girls. So then you can choose 1 out of the 9, and then you times it. It's like a branching business going on. If you have A, B, C, D, you branch out like that, and that's basically what's going on in this business right here. So you end up having 9 factorial inside. If you change the question around, you ask for if the question wants you to have 2 girls on the end, then all you have to do is, if you have 6 girls, then you end up having 6 in between. You end up having 6 at the end, and then 5 at the end, and then the rest in between. So you still have 9 factorial. 9 factorial doesn't change, but what does change, depending on whether you want girls or boys, is the end value, the end seats. And that's basically how you do a problem like that. I think that was on the test. Alright, next problem. Comment if you have any suggestions of how I should teach this material. And oh, by the way, the answer is 7,257,600. Okay, that's the answer. When you times 6 times 5 times 9 factorial, you get that. You get that. Alright. Next. What is the probability of getting 1 correct answer out of 5 true/false questions if an unprepared student randomly guesses? Okay. This problem is pretty simple. Pretty simple, right? All you have to do is have the probability of getting 1 correct answer. Just for a second, pretend that order does matter. Saying like, oh yeah, you have to get the probability of getting 1 correct answer, and the 1 correct answer being the first answer. Okay? First answer, second answer, third answer, fourth answer, fifth answer. Okay? So I want to find the probability of this. What is the probability of getting correct answer? 1 out of 2. 1 out of 2. Wrong, 1 out of 2. 1 out of 2. 1 out of 2. So we've seen this. This is just 2 to the 1/2 to the 5th, right? Okay. Well, what if order doesn't matter? What if you can get the second one right, you can get the third one right, and the first one wrong? Well, then it's OR, right? It's just C, W, 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 and then OR the probability of W, C, W, 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 and then so forth, so on and so forth. So when you have an OR right here, you have a plus, right? You're plussing these probabilities. So you have 1/2 that plus 1/2 that, and you go on and on 5 times, because you can have the correct answer in the first one, second one, third one, fourth one, and fifth one. So you have to times it by 5, and you end up with 5/32, right? Because 5 times that, right? So you end up with I should really look at this screen right here, because you guys can't see this. Okay, there you go. You see what I'm saying? Yeah. And they're ORs, so all you do is just plus the probability. Next problem. Okay, so I'm running out of time. I want to do one special problem.